Good afternoon once more, learners and the colleagues. A continuation of yesterday's session, where we were talking perimeter and area of the 2Ds. And what I emphasized yesterday is to remember the properties of your 2D shapes. They are square, of course, all sides are equal, opposite sides equal, and parallel. All the angles 90 degrees. That's very important when you do your calculation. Rectangle is the same. Opposite sides equal and parallel. Angles 90 degrees. And it's important to know all those properties so that when we calculate the area or perimeter, then you know all the dimensions, you know the base, you know the height, and the relationship between the sides. Like I said yesterday, you still remember the perimeter is around the border, the boundary that closes in or that keeps the shape inside. The boundary, the edges, the fence, the surrounding of the shape, like you see the triangle on the right hand side, the perimeter, like I said, measuring the outer part, the surrounding part, the boundary, the border, and the area is the space inside those borders, the space inside those boundaries, the space inside that fence, the yard surrounded by your fence is your area inside the shape. As you can see there, perimeter of a rectangle, you add all the sides A, B, C, D. The square, same thing, you add all the sides, the boundaries, the border, the fence, the outer of the shape. And the triangle is the same thing, A, B, C. You add all the sides. Your trapezium, A, B, C, D, E. The surrounding, the area around the surrounding. Perimeter, once more, just a quick picture there. Perimeter of your square, you add all sides. Area of the square, you multiply side by side, where you have your two sides there. Same thing with a rectangle. The perimeter, you add two longer sides, or you add the width, two of the width, two of the length, or adding all of them, which should give you a perimeter. And of course, your area is your length by width there. You multiply it. And remember, the triangle is half of a rectangle. Therefore, the area of a rectangle is based by height. But now, because the triangle is half of it, so we say half of base by height, and of course, perimeter A, B, C. We will also be touching a circle today. What is around a circle? Your perimeter of the circle is called the circumference, which is represented with the letter C, which is equals to 2 pi r. 2 pi r represents your circumference, represents your perimeter, and of course your area is pi r squared. Quickly, the area of a rectangle, again based by height, inside those sides. An area of parallelogram, same thing, is spaced by height, but it's important to distinguish where your height is. And as we said earlier on, triangle is half of your rectangle. Therefore, it's half of that base by height when you look for the area of a triangle. And a trapezium or trapezoid, you add your parallel side, half of sum of your parallel side by the height once more. By the height once more, half of sum of parallel side by the height. Right, the square, like we said, your base by height, as is in a rectangle, but divided by 2. And your square length by width, so is your rectangle. But what I said is important is to remember the properties of your 2Ds. Right. Right, again there, when you look at the area of A and B, in this case, our trapezium, you add all of the inside of the rectangle, sometimes you'd approach it that way, find the area of the triangle, which is A, and then find the angle of B, which is a triangle. You add the two. They are combined, so mathematically, you are adding them. Therefore, your rectangle will be 3 multiplied by 4, which is 12 centimeters, and your area of a triangle is 1 centimeter by 4 centimeter on one side by other 4 centimeter, divide by 2. Divide by 2. All right, here is just to show you the relationship of a rectangle and a parallelogram. Parallelogram and a rectangle. In other words, when you look at the first figure, it's when you move that triangle to the left, it will give you the rectangle. Hence, the area, calculating the area is the same. Just an indication here. Like here you can see, here is your base, is 7 centimeter, and your height, your base is 8 centimeters, sorry, and your height is 7 centimeters. And remember, the height basically means the space between those two parallel sides or those bases. Both of them, they can be base. In this case, we take the one below as your base, and of course, base by height when you look at it. Same thing here, when you look at the rhombus, all sides are equal. All sides are equal. And again, we still say length by height or base by height is the area of a rhombus. The perimeter, of course, you add all 4 sides, which is length by length plus length plus length. There are 4 of them. Quickly, circumference. I earlier spoke about circumference. It's so important to understand what's circumference. A perimeter around your circle, surrounding the circle, that bounds in the internal part, which is the area, is called the circumference. And circumference is defined from your pi. And your pi, the relationship of your pi is circumference, the ratio of a circumference and the diameter. In other words, you compare the length of a circumference and the diameter, which is your pi, and then your circumference, you get it from there. When you cross multiply, circumference will be a diameter by pi or pi by diameter. But also don't forget that diameter is made out of a radius, two of them. A radius is half of a diameter. So hence you say circumference is 2 pi r or pi diameter. That's what the circumference means. Circumference, again, the length around the circle, the perimeter around, the boundary around the circle, and what is inside that perimeter will be our area, which is AR squared. AR squared, area of a circle, AR squared. Properties are important. The figure on my left of your right is a rhombus because all sides are equal. Also, be aware that diagonals bisect each other of a rhombus. Also be aware opposite angles are equal. Those properties are important when you calculate your area, your perimeter. The Pythagoras will also be coming into the picture because where the diagonals are intersecting, they meet at 90 degrees. They meet at 90 degrees. Therefore, you can get your hypotenuse there. Same thing when you go to your kite on the right. On the right, the longer diagonal bisect the shorter diagonal. The adjacent sides are equal. So it's important when you look for the area of a kite, the triangle on the left have base by height, the triangle on the right have base by height. When you look at that one, that question there, if JK is 8 centimeters, you note your JK is 8 centimeters, your KL is 14 centimeters. Then if you know the properties of a kite, then it means JM is 8 centimeters and LM is 10. Sorry, JK 8 centimeters, which is equal to JM, which is 8 centimeters. KL is 14 centimeters, which is equals to LM, which is 14 centimeters. KM is 10 centimeters. But remember the property that the longer diagonal bisects the shorter diagonal. Therefore, Kn will be 5 and then Nm will be 5 centimeters. So the properties are important to remember. Another important thing in our 2Ds, area and perimeter, in our measurement, we have to convert from centimeters, maybe you'll be given in millimeters, you're expected to convert to centimeters, kilometers to meters. So remember, when the higher you go, you multiply. Let's start with the millimeter, which is a small one, When you go to centimeter, when you convert to centimeter, multiply by 10. From centimeter to meter, you multiply by 100. From meter to kilometer, multiply by 1,000. And when you do the opposite, you divide. Remember, multiplication and division are the opposite. So remember that from millimeter to centimeter, 10. From centimeter to meter, 100. Therefore, meaning from millimeter to meter, it will be 100 by 10, which is 1,000. So it's very, very important to remember that. It's very important to remember that when you convert. Perimeter, as we said, understanding that it's the distance around. When you go around that rectangle, how many units will be stepping? 8 units plus 5 units plus 8 units plus 5 units, which is 8 plus 5, 13, plus another 5, 21, and plus 5, which should give you 26, 8 and 5, 13, 8 and 8, 16 plus 5, 21 plus 5, 26. So area around the measurement around. And then the area, of course, you multiply your units. 8 units by 5 units, how many is all in all, you'll be having 40 units. You'll be having 40 units when you go area. When you go to the Prink diagram there, you also have to divide it into different composures. It has got different rectangles there. And of course, for your perimeter, you go around, you add 3, 4, 1, 2, 4 plus 6. You add all of them. And your area, you separate them, the two, work at the bigger rectangle and a smaller triangle. And then when you go to the yellow one, of course, your area is 3 by 4 units, and your perimeter will be 4 plus 3, which is 7 plus 4, which is 11 plus 3, which is 14, which is 7, 4 plus 4, 8, 3 plus 3, 6, which is 14 all in all. Same thing, the other one on the right, you've got 2 rectangles there, the longer one and the shorter one. And then, of course, you'll be going units around when you look for your perimeter. Like I said, the properties are important. An area of a rhombus is half the product of the diagonals. You multiply your diagonals and half of them. That's area of a rhombus. In other words, you've got 24, you've got 18, and then 18 by 24, the product and half of that. Or in other words, half of diagonal and half of diagonal, you add the two, but it's half the product of the diagonals. Same thing here. When you look at that kind of question, the area of the shaded shapes. Your shape A there, the blue one, the area inside the boundaries, you add your parallel sides. 12 plus 15, half of that, which is 7.5, multiplied by 8, which is the area of your trapezium. Figure B, you can look at the area. You can do it in whichever way you want because it's a parallelogram, which is base by height, which is 10 by 50, or you can say 10 plus 16 by height trapezium and calculate the area of a triangle on the side. Area of 2D shapes there. Remember trapezium, you add a parallel side, and then half of it multiplied by height. Again, you get questions like this. In this case, you see you've got two semicircles, and when you add two semicircles, they give you a circle. You've got a rectangle as well. So in other words, half a circumference is a perimeter of another circle. Half a circumference is perimeter of another circle, or the whole circumference, if you add the two, that will be a perimeter of half a circle and half a circle. And of course, the side DC and the side AB. And then for the area, half pi r squared for other semicircle, half pi r squared for other semicircle. You add it, and then, of course, the area of the rectangle. So from tomorrow, we'll be revising by doing calculation practically everything from perimeter to the area. And I hope this will assist you in when you attempt your test. Good luck.